What is this? This is a bench. What is this? This is a mark. Benchmark! Don't leave me! As you know, I recently built a new PC, and this is the benchmark of that new PC. Now, what's the point of benchmarking? Well, it's a fun thing for us enthusiasts to do. It gives us something of what we can expect out of our components when we do some of these benchmarks, especially when it comes to CPU benchmarks and graphics benchmarks as well. In reality, we can see how our PC is performing. We can see if we have any room for overclocking, or if there's components that are being throttled because temperatures are too high. The one app that I will be using to monitor the performance of my computer is HW Monitor. This is a free app that you can download off the internet, and it can tell you a lot about the components of your computer. It can tell you temperatures of your cores, it can tell you the voltages of the cores, the temperature of the CPU itself, how much power is being drawn to each core, which is really nice, as well as the clock speed of each core. So if you're looking at overclocking, this will be able to tell you accurately how much you have overclocked your computer and give you accurate readouts for that overclocking performance. In addition, it can tell you the temperatures of your GPU, the fan speeds of your GPU, and the fan speeds of any other fans that are in your PC that you've added. In my PC, I just got an AIO cooler. I believe it's a 120 millimeter cooler that comes with the NZXT H1, so I won't have to necessarily worry about those fan speeds. What you can really do with all this data is you can understand how far you can push your components, where you might need to have adjustments so that your temperatures don't end up throttling your components. You can go into the BIOS of your motherboard, you can set custom fan curves, you can go into overclocking software and applications to overclock your processor, to overclock your GPU, as well as undervolt some of these components, which can help immensely get the most and best performance out of all your components. I don't plan to do a lot of gaming, and the majority of my work is creative, so I do a lot of rendering either in Premiere Pro, DaVinci Resolve, and After Effects. My hope is to test my computer and see how they do in some of these tests, and maybe it would give me an accurate representation of how some of these programs would utilize my components as best as possible to give me the smoothest workflow as possible. A lot of people will run these benchmarks for 1 to 2 hours sometimes, because that might be representative of how long they game. I'll be running most of my benchmarks in the 20 to 30 to 40 minute at most, and that may not be accurate for you, but for me that's essentially what a render time at most would take for me. So keep that in mind when I share some of these results with you, and how that is affecting my computer and how that sort of plays out into my workflow and sort of what's realistic for me. Okay, so I've done all the benchmarks and tests, and let's share some of the results. And what we'll do is we'll actually compare it to my MacBook Pro. I know there's a caveat. I'm comparing a laptop to a desktop PC, but I used this laptop solely for editing for the better part of 4.5 years. It'll be not entirely a fair comparison, but something to just have fun with and really see the difference in computing power. So we'll start with Cinebench. Now, Cinebench R20 for the CPU, I got a score about close to 5,000. In this case, it is a 4,883. Compared to my MacBook, 2-core, 4-thread, 848. You can see the difference in compute power, and that's absolutely have to do with the amount of cores. You've got 4 times as many cores. You've almost got 12 times better performance out of the CPU. With Geekbench, you can see the multi-core score, 9,038, absolutely insane, compared to the MacBook Pro multi-core score, which is around 2,000. It's almost 5 times as fast, which is something you can actually extrapolate from Geekbench. Twice as much means twice as fast or twice as better. And in this case, it's about almost 5 times as better when it comes to multi-core processing. The interesting thing though is single core score. They're a bit closer together, you know, only twice as better as the MacBook Pro. And I think for things like photo editing, like using Lightroom or anything like that, the MacBook Pro would still have a good place for image processing. Not all hope is lost for single core computing when it comes to the MacBook. So the next thing I'll go through is another GPU test, and that is the Unigen Heaven benchmark. And during this Unigen Heaven benchmark at 1080p, I got about 300 frames per second. Well, that's the max frames. The average is 172 frames per second. So if I'm gaming at 1080p, this system can definitely handle it. And you'll also notice sort of the temperatures as well up here on the top right. So the max temperature that this graphics card reached in about a 20-30 minute test was 71 degrees, which is reasonable. If I really wanted to push it, I should probably test it for a longer period of time, which would be an accurate representation of how long I would be gaming. But I think 71 is, I'm happy with that. If I had a vented front panel, those temps might drop a bit. The next thing I did was something that's really specific to me, is a render test to see how long a project would render. And so I had a 15-minute timeline, same footage, same sequence, and I rendered it on my MacBook Pro, and I rendered it on my PC. The PC, with CUDA and NVENC encoding through Premiere Pro, took 5 minutes and 31 seconds. On the MacBook, that same encoding took 1 hour and 10 minutes. Absolutely insane. The MacBook is not leveraging any CUDA cores or any specific graphic aided encoding because it doesn't have an NVIDIA graphics card that it could leverage. So all of that encoding was CPU based, and with a 2-core 4-thread CPU, it's gonna chug. So I'm really glad to see that test blown out of the water with the PC, because this is exactly what I'll be using my PC for, is video editing and video rendering. So the last test I'll talk about is a GPU test as well, and that's Blender. So Blender is great because it actually plots your data and you can visualize it compared to other processors that do graphics processing, as well as other GPUs that are already on the market. My GPU, the RTX 20 Super from Gigabyte, kind of ranks in the top 20th percentile, which I think is really crazy. And my Blender time was about 20 minutes and 12 seconds, and the CPU temps got to about 75, 76 with Blender. So in this case, it gives you 6 images and they'll render it. I think the BMW was a photo, so it didn't take any time at all. And the longest one was this 3D graphic Victor that took the longest. But compared to other graphics cards, you can see where your graphics cards lies on this plot and which ones are, I guess, inferior. Take that with a grain of salt, because if you're getting the best out of your graphics card for your needs, nothing really is inferior. And you can see where the better graphics cards lie. You know, I'm happy with this. With these benchmarks, take it with a grain of salt. If your components do what you need them to do and they're not getting throttled or choked, then you've got yourself a good setup, because your life is made easy and your components and tools are working for you and not against you. So let's compare to something similar from the Mac world in the desktop space that would be comparable to my NZXT H1 build. In terms of benchmarks, from a Geekbench perspective, and I think I'll only be using Geekbench in this case, do correct me if I'm wrong and I'm overlooking and oversimplifying these things, but I'll have a few caveats at the end to some of these comparisons. So something similar from the Mac world, we're looking at a Intel Xeon 10 core, 3 gigahertz processor. And that's about the similar score. I mean, 500 points more, that might equate to some performance benefits, but in terms of score and just numbers, it's similar. It's in the ballpark in my opinion. So if you look at it from a cost perspective, this iMac cost about $6,300, and frankly for me is quite far out of my price range. What you may be getting is that benefit of a smooth integration with hardware and software and drivers. Macs are optimized really well, and I think people value that a lot. What about the new Mac Pro that entered the market just last year in late 2019? So something comparable to my system would be this one here with the Intel Xeon W8 core processor. You know, it's got 8 cores and the score is about 1,000 less. Maybe it could be considered in the same ballpark. And the cost of that, $7,500, right? You look at some of the comparisons in terms of what the benchmarks say on paper compared to the price. And then, you know, a lot of people are gonna be like, well, why would I pay so much more for an Apple product when I could get something, or I could build something from the PC world for a lot less? And, you know, price to performance ratio, I think, is a big thing. And for me personally is what sold me on the PC world. And I don't need a $7,500 machine just to render 4K timelines. I could get away with something significantly cheaper for my work. What have we all learned with all these benchmarks, you know? I've been an Apple fanboy for too long. So, I mean, for me personally, I needed something that was within my budget that could render 4K seamlessly. The key for me was getting a video editing rig for a decent price. So I definitely did have fun benchmarking some of these components to see how far they can be pushed, what some of the thermals are, and what type of performance I'm getting out of these components. So I hope you found this video helpful, maybe educational, what you might use for your own benchmark tests. And if you like it, give it a thumbs up. Hope you subscribe, and I'll see you guys in the next one. Peace.